Need of yarn. In this session, we are going to learn why do we need yarn. We had looked at SDFS architecture and also how job tracker and task tracker perform together in order to get computing for big data, where data is stored in SDFS. We also had a look on different kind of master-slave federation architecture, right? Now we are going to look at computing part of it, where we had the job tracker and then we have many task trackers. As we know that job tracker schedules tasks to the task trackers using some round robin algorithm, right? Now let's say that we have three task trackers, TT1, TT2 and TT3. Let's say 4 MB, 8 MB and 4 MB machines are these. We have job tracker and we have job J1, 2 MB, job J2, 2 MB, job J3, 4 MB. Now if I am going to ask you how these jobs get scheduled, J1, J2, J3 are the jobs submitted to job tracker by the client in sequential manner. Now J1 scheduled to which task tracker? By the job tracker. How does it get scheduled? We schedule them in first come first serve mode. So it will be TD1. What about the job J2? Let's say this is 2 MB job. Where does it get scheduled? TT2. Now we have J3. Where will J3 goes? 4 MB job. Obviously, it will go to TT3. This is normal scheduling of round robin that job tracker will perform to schedule its job in sequential manner. There is no doubt about it because job tracker is dumb. All it needs to do, schedule its job. It performs nothing other than dispatching the job to the right task tracker. What's the problem we got here? What is the problem we got when we scheduling J1, which is 2 MB job, to TT1? What are we consuming or what are we wasting? We are wasting memory. How much memory we are wasting in TT1? It's 2 MB. Now how much memory wasted in TT2? It's 6 MB. Or what about TT3? It's 0 MB. Now another job comes which is going to take, let's say 4 MB job J4 comes. What will happen to this job J4? What do you think will happen to job J4? Here all the jobs, will it go or will it pending for some other task to complete? It will go into job tracker queue to get queued in it so that one of this task complete that can be assigned provided memory is available to execute that job. We got the resources to execute the job. Now these are two conditions. One was memory was being wasted and second thing is there is unnecessary queuing up of jobs. Here question is why it won't go to task tracker 2 as we have 6 MB space. And second question is, does job tracker have any knowledge of memory to schedule it? No, it's just round robin scheduler only. Any algorithm, it's only scheduler. Now what is round robin scheduling? Round robin scheduling is just that as when jobs come, schedule it to the processor that is empty, that is idle. As long as processor is not idle or active, the round robin scheduler wait for the processor to become idle. To schedule another job, that's the reason the job goes to pending queue and then going to execution queue of task tracker 2. How do we overcome this problem? In a cluster, we have so many machines with different kind of memory requirement and processor requirement, right? We have heterogeneous clusters. Some machines have lower memory, some machines have higher memory. How do we put our design into place? So that we could leverage the resources that we got in the cluster for an effective scheduling of jobs and execution of jobs to fetch results for us. By having something called resource management built into where? Which node needs to build resource management? Built into the job tracker. Now let's revisit by building the resource management. We have TT1, TT2, TT3 and job tracker. And we have 4 jobs, J1, J2, J3, J4. TT1 is 4 MB, TT2 is 8 MB and TT3 is 4 MB, right? Now let's assume job tracker has knowledge of memory existing with its task trackers. So let's say it keeps map TT1 totally 4 MB available, TT2 8 MB available, TT3 4 MB available. Now the first job comes, where it will go? TT1. Second job comes, where it will go? TT1. Third job comes, where it will go? TT2. Fourth job comes, TT3 or TT2? It's TT2. Now how much memory is vested here in TT1? It's 0 MB. In TT2, how much memory vested? It's 0 MB. In TT3, we still got 4 MB left. By just building something called a resource management in the job tracker, we could schedule all the jobs we got, and in addition we got a machine of cluster still waiting to process request. Don't we think it's very wise thing to build job tracker in this manner? And don't we think this is using the cluster in more effective manner? Right? Just by building some sort of resource management algorithm. Now how does it actually work? Let's look at job tracker and task tracker. Whenever a job comes to job tracker finds out the memory needed for the job, and then it asks task tracker, can you serve this job? Do you have memory to serve this job? Now the task tracker will reply yes or no. Yes, because it has 4 MB memory and job which is submitted is just 2 MB job. J1 is. So it could serve it. So it will give an acknowledgement. Once acknowledgement happens, job gets submitted to particular task tracker. Now when next job comes, the same process repeats. Request and then got the acknowledgement. For the next job, it's going to ask TT1. TT1 is going to say either yes or no. What will it say? For job J2, it will say yes. Because it still got the memory, so it say yes and it gets the job J2 allotted. Now when J3 comes, it's going to do the same thing. Can you serve this job? TT1 is going to say no. And it goes to next task tracker available in the cluster to perform the job. So it's going to ask next TT2. Are you ready to take this job? TT2 is going to respond yes or no. What do you think? It will be say yes. So the job gets scheduled to TT2. In the similar manner, the resource is being negotiated between task tracker and job tracker. That's why this process is called resource negotiation. And that's why this whole algorithm on which Hadoop is working by building the intelligence into the Hadoop framework for computing is called YARN. YARN stands for Yet Another Resource Negotiator. This is the biggest change in Hadoop 2.x when we compare with Hadoop 1.x. And now in 2.x, Job Tracker is no longer a master. So it's called Job Tracker is known as Resource Manager. Similarly, the Task Tracker is slave, but it's not a slave anymore because it's sort of negotiating process that happens. So Task Tracker is called a Node Manager. Now we got two parts. Computing part is YARN and the HDFS part. In the Hadoop 2.x, computing part is called YARN. Hadoop 1.x, it's called MapReduce. HDFS comprises name node, data nodes, and secondary name node. And YARN comprises what? Resource manager and node managers. And these are the 5 daemons that exist in the Hadoop. For the Hadoop to work in cluster mode, whether it could be full cluster or pseudo cluster, it needs to be having all these daemons running onto the machine. Okay? Thank you very much.